Howdy, it's me, friendly neighborhood AP Calculus teacher, back with another AP exam review video. This time, topic 4 on area and volume. Little change to the format here because of some technical issues. I'm only going to go through the scoring guidelines with this question. I'm not going to show you my work. So, this question is a calculator permitted question. When you try it, make sure you do that. In general, area and volume questions require you to find intersection points, both with and without a calculator. How do you know which one to use? Well, you ask yourself, do I have a calculator? If you have a calculator, use the calculator. Do not try to be an algebra hero. And because you're using the calculator, make sure you have recently brushed up on storing values from graphs. Other skills include area between curves, volume of revolution around any horizontal line, so anything that's the x-axis or y equals some value. The axis of revolution can be above or below the region. It will never be through the region. Any vertical line, so the y-axis or any x value could be to the left or right of the region. It will not be going through the region. Also, volumes of known cross sections. So the square, rectangle, those ones are pretty fine usually. Semicircle, key thing to remember is that the length that you find across the region is the diameter, and you need the radius to get the semicircle's area. For triangles, there are many types of triangles. They'll be very clear about what kind of triangle they're looking for. Perhaps the most common to occur is an equilateral triangle, and you could use an equilateral area triangle formula of the square root of 3 divided by 4 times the side length squared. As to why that happens, that is trigonometry, which is beyond the scope of what we're looking at. If you are a BC student, there will be a question potentially part about arc length. So make sure you remember your arc length formula, the integral from A to B of the square root of the quantity 1 plus the first derivative squared. You're just squaring that first derivative. Often you need to write down the first derivative to receive full points dx, of course. And furthermore, on the BC exam, a lot of times the area and volume and arc length end up being multiple choice, but not always. They don't have to be. And for non-calculator questions, it is quite common to have setups and not evaluate. Save yourself the time, reread the question before you start solving. Make sure you do in fact need to find the value. Okay, without further ado, hopefully you will try this question, and then you'll get more out of me talking about the scoring guidelines. Scoring guidelines are up next. Went too far, sorry. Okay, part A. Find the sum of the areas of regions R and S. Now, this was a very nice way to phrase this question because a lot of times you might just be told to find the area bounded by the curves from x equals 0 to x equals 2. Make sure you read things carefully and you're paying attention to what you need to do. So R has an upper curve of g. So you can write it as g. You can do x to the fourth minus 6.5x squared plus 6x plus 2. I know you can find an antiderivative there. Do not. This is a calculator question. You want to do that completely on your calculator. So you do that from the intersection point. Make sure you store the x value and the y value of the intersection point. You do that on the graph part of your calculator. They called them A and B. You don't have to call them A and B. But A corresponds to the x value. So the second interval starts at the x value A, 1.033 to 2. Again, use the stored value. This time, the function f, 1 plus x plus e to the power of x squared minus 2x. That is the first function. And then scoring 1 point for the limits. So you need to go from 0 to the x value of the intersection point and the x value of the intersection point to 2 for the second integral. Integrands, that first chunk from 0 to the intersection point needs to be g minus f or something equivalent. And the second point needs to be f minus g. And then you get your fourth point here from the correct final answer, accurate to 3 decimal places, 2.004. For part B, we're focusing only on region S. So that one was F minus G. And we would like the volume of a solid, and we know that the cross section perpendicular to the x-axis is going to be a square. Now, it's a good thing this is perpendicular to the x-axis, because if this was perpendicular to the y-axis, this would be a beast of a problem. So perpendicular to the x-axis means I'm using x values for limits of integration. I'm using x-valued functions and dx. If I were perpendicular to the y-axis, y values, y-valued functions, and dy. But it's f minus g, we square that. S starts at x equals 1.033, goes to 2, again, store 1.033 and use the stored value. You need to be accurate to 3 decimal places, 1.283. That's your answer point. You get 2 points for the integrand, the order, and the squaring, and of course, the limits integration. Part C. H is the vertical distance between F and G in S. Find the rate at which H changes with respect to X when X equals 1.8. So H is subtract the Y values. That's how you get vertical distance. So that's F minus G, H prime is F prime minus G prime, and then evaluate both. Again, do it on the calculator. I know you can do those derivatives. Do not do the derivatives. Do them only on the calculator. So if you have H prime, it's unclear if considers means you need a correct value of H prime. So you need to say F prime minus G. I think you don't. I think you just need to have mentioned you're going to look at H prime. And then the correct value, accurate to 3 decimal places, rounded up, negative 3.812, which brings us to the end of topic 4. Area and volume. Thank you very much for your attention.